Hello everyone, in today's lecture we will discuss about the curvature of a manifold. Students, while dealing with manifolds, we may have spaces of positive curvature, negative curvature or flat, or you can say the Euclidean spaces, because all the laws of Euclid hold only for the flat spaces. Now students, if we draw a triangle in a space of a negative curvature, then it actually looks like this one. For a flat space, the triangle can be drawn as this one, where the sum of all sides of a triangle in a flat space is equal to two right angles, means 180 degree, and there can be only two right angles and there cannot be more or less than two right angles when we draw a triangle in a flat space. Similarly, for a space of positive curvature, the triangle looks like this one, where the sum can be equal to 270 degree, means three right angles, and there can be three right angles in a non-Euclidean space. Similarly, in a non-Euclidean spaces, the parallelogram will get overclosed or gap left when we draw it. For example, when we draw a parallelogram in a space of negative curvature, then it will get overcloses and it actually looks like this one. And in a space of positive curvature, the parallelogram looks like this one, where a gap is left behind. For example, if you draw a parallelogram on the surface of a sphere, then it actually looks like this one. Now students, we will define the curvature. For example, we have a parallelogram in a space of positive curvature. Now student, this is the point. When we reach this point from two different sides, then there is a difference left between the two resultant vectors. For example, first of all, I will take a vector and move this way and I will get this vector, and then after that I will take a vector and move from this direction and I will get this vector. Now students, then there is a difference left between the two resultant vectors, means there is a difference that is left behind between these two resultant vectors, and we are saying that these vectors are these two. Okay, like first of all I approach this way and then after that I approach this direction. Now students, curvature is given by this one, means the difference between these two resultant vectors, that is equal to the curvature, and we can define it as: we carry a vector along two sides of a parallelogram, and noting the difference between the resultant vector and the vector obtained by carrying it along the other two directions gives the measure of the curvature. Means we will take a parallelogram and we will take two vectors along different directions, and then after that we will note the difference between these two vectors, and the resultant of these two vectors will give us the measure of the curvature. Now students, this is all about this lecture. In the next lecture I will discuss the derivation of the Riemann curvature.